Here's a challenging middle school math problem involving fractions. You can solve the problem any way you want, but I'm going to solve this problem visually. You can use simultaneous equation, which of course we quite don't expect middle school students to use. So there are other ways of solving it. So I would encourage you to try the problem on your own without looking at my video. See if you can solve it. If you cannot solve it for some reason, feel free to watch the entire video. So let's go ahead and read the question. Originally, the number of girls and the number of boys in Miss Mckennitt's class was the same. 1/3 of the boys had to move to another class, and 2 times as many girls as the number of boys that moved to another class joined Miss Mckennitt's class. If there are 56 students in Miss Mckennitt's class now, how many students were in her class originally? That's our question. So go ahead, give it a shot, solve the problem on your own. I will solve the problem visually. So what we have here is a pictorial representation of the original scenario. In the original scenario, we had the same number of girls and boys in Miss Mckennitt's class. However, 1/3 of the boys left, so I'm going to cut the strip for the boys and for convenience for the girls too in 3 equal parts. This is 1/3. This is 1/3 of the boys, and my handwriting is not the best when I'm using the mouse to write. Now, this many boys left, and twice as many boys as girls joined. So here, I'm going to put 2 more chunks, assuming they're the same size as the blue chunk that left here. So this is our new scenario. This is the situation now. Only 2 blue chunks, and let me see if I can draw the rectangle using pink. It won't be the same shade, but certainly a little more consistent. So that's what's going on here. This part is missing, but 2 parts of the same size joined. So original scenario was this light pink strip and the light blue strip, and the new scenario is 2 parts of the blue strip and the original pink strip plus 2 more thirds of the pink strip. So that's how we're going to solve this problem. That's a brief outline of our solution. So what I have here is an explanation of the problem scenario, which we actually have already done once. This is my original scenario. Original. This is the latest scenario, or the current scenario. Okay, as explained, this was missing, and then 2 more pink chunks were added. Now I do know one thing, that all these students, the boys and the girls, right now they add up to 56 students. Now you have to understand, all these little pink and blue rectangles are the same size. They represent the same number of students. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 rectangles representing 56 students. I have 7 rectangles representing 56 students. So each rectangle must represent 56 divided by 7 is equal to 8 students. So each rectangle must represent 8 students. So I'm going to write here, if I can, 8, 8, 8, a bunch of 8s, oops, let me put it here if you don't mind, just a little above that. I want to see the number. Now take a look at it. 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8, or 8 times 7, 1, 2, 3, 4, 5, 6, 7 is 56. I have 56 students. However, I'm not quite finished. The question says, how many students were in her class originally? Well, this is the original scenario. If each piece represents 8 students. She had 8 students here. Of course, you know where I'm going with it. 8 students here, but I'll be writing all those numbers. I know some of you can do it in your head. 8 students here, 8 students here. So how many students were here originally? Of course, you can add 8, all the 8s, but you can also do 6 times 8 is equal to 48. So the answer is, originally Miss Mckennitt had 48 students. Now she has 56 students. That's our answer.